Today, I'm talking about indefinite integrals and the net change theorem. Firstly, we discussed about indefinite integrals. Indefinite integral is similar to antiderivative when large f prime x is small fx, and large fx is called antiderivative of fx, as you know. So when we use integral notation, integration without lower limit and upper limit, fx dx is large fx. This large fx is called indefinite integral. So indefinite integral is another expression for antiderivative using the integral notation. So we need to know some characteristic about indefinite integral. These two characteristics explain the linearity. The indefinite integral constants multiply fx dx is constants multiply integral fx dx. The integral fx plus gx is integral fx dx plus integral gx dx. And integral k dx is kx plus c. So when we perform indefinite integral, always this constant is occurred. This constant is the integral constants, and it means kx derivative of kx plus c is k, regardless of c. For example, kx plus 1 derivative is k, kx plus 2 derivative is k. This is the same because the derivative of the constant is 0. So we have to add the integral constant c always. So this integration is definite antiderivative of x to the power of n plus c. This is definite integral. So definite integral sin x dx is minus cosine x. Cosine x is the antiderivative of sin x, and plus c. We have to add the constants always. So it means when we take a derivative for minus sin x plus c is minus cosine x plus c is sin x when every constant c. So this is antiderivative is cosine x is sin x plus c. always definite integral always has the constant integral constants. And second antiderivative of second square x is tangent to x, and we have to add integral constant c always. And cosec square x is minus cotangent to x, and sec x tangent antiderivative of sec x tangent to x is sec x, and derivative must add the integral constant c. So definite integral cosec x and cotangent x dx is minus cosec x plus c. So I will take an example to find general indefinite integral. Indefinite integral has no lower limit and upper limit. So this is integral n 10 multiply integration x to the power of 4 dx minus 2 integration sec square x dx. So antiderivative of x to the power of 4 is 10 multiply 1 over 1 plus 4 x to the power of 5 and minus 2. And sec square antiderivative of sec square x is tangent x, and definite integral always have the constant c. So the answer is 2 x to the power of 5 minus 2 tangent x plus c. C is constant. This is the answer. And we take another example. Integration cosine x over sine square x. This is the integration cosine x over sine x multiply 1 over sine x d theta cosine theta over sine theta multiply 1 over sine theta d theta. It becomes integration cotangent theta multiply cosec theta d theta. We have already known antiderivative of cotangent theta multiply cosec theta is minus cosec. This is minus cosec theta and plus c. C is must be included. So next example is this is a definite integral. This integration has lower limit, both lower limit and upper limit. So we firstly we have to find antiderivative of x cubic minus 6x. This is 1 over 4 x to the power of 4 minus 6 multiply 1 over 1 plus 1 x to the power x squared, and from x equals 0 to x equals 3. This is 1 over 4 x to the power of 4 minus 3 x squared from x equals 0 to x equals 3. And we can find when we input x equals 3 and 1 over 4, 3 to the power of 4 minus 3 multiplies 3 squared. When we put 0 in the this formula, this is 0, so this is 81 over 4 minus 27, and this is 81 minus 108 over 4. This is a minus 27 over 4. This is the answer. And next example is also a definite integral. Find definite integration from 0 to 12 x minus 12 sine x dx. Firstly, we have to find antiderivative x minus 12 sine x. This is 1 over 2 x squared and minus 12 minus cosine x from x equals 0 to 12. This is 1 over 2 x squared plus 12 cosine x and x equals 0 to x equals 12. Firstly, we input x equals 12 into the this formula. This is 1 over 2 12 squared plus 12 multiply cosine 12 minus we input 0 into the this formula. This is 1 over 2 multiply 0 squared plus 12 multiply cosine 0. This is 0 and cosine 0 is 1. So this is 12 multiply 12 and 6 and 72 plus 12 cosine 12 minus 12. So the answer is 60 plus 12 cosine 12. This is the answer. And next example is, this is a definite integral. So we have to find antiderivative of this integrand. So this is integration. This is integration from 1 to 9, and this is 2 plus t to the power of 1 over 2 minus t to the power of minus 2 dt. So antiderivative of integrand is integration. This is 2t plus 1 over 1 plus 1 over 2 t 1 over 2 plus 1 minus 2 plus 1 and t minus 2 plus 1 from x equal 1 to 9. This is 2t plus 2 over 3 t to the power of 3 over 2 minus 1 and minus 1. This is a plus t to the power of minus 1. This is 1 over t, and t equal 1 to t equal 9. When we input t equal 9 into this formula, and this is 2 multiply 9 plus 2 over 3 multiply 3 square 3 over 2 plus 1 over 9 minus, then we input t equal 1 into this formula, 2 plus 2 over 3 plus 1. So this is the answer. This is the answer for this question. And next topic is the net change theorem. Our purpose is to find the net change from starting point to end point of some variable. So the net change theorem, the net change is the integral. The net change of some value from a to b is the integral of rate of change. Is the net change. We have to find net change fx from x equal a to x equal b, and this is the rate of change integration from a to b. This is net change theorem. We take an application using net change theorem. First application is the volume of water in the reservoir at time t. This is we net change of the volume of water. Where water is the rate of change of volume and integration from 0 to t dt. This is net change of volume of water. The net change is integration for the derivative the variable. The second application is concentration of products of a chemical reaction at time t. So we net change is the derivative of concentration of products. It means concentration of product is, if we let concentration of products be c prime t, and if we want to know net change from 0 to t and integration 0 to t dt. This is the net change of concentration of product. This is the ct, and integration the rate of change. Rate of change means the prime, the derivative. So mass of load from left to n to 0. The mass of load and 0 means net change of mass x, and left side, if left side is 0 to x. This is the mass of load from left to epsilon charge. What is it? The physical meaning is m prime. M prime is dm over dx. This is the mass density per length. So this is integration m dx from 0 to x. So this is the answer. And next application is population change. If we let the population is p, the net change is derivative, rate of change of t, integration t1 and t2. This is the population net change of population. The marginal cost is the same. Marginal cost is cost prime the integration of cost prime from a to b. This is a marginal cost net change. So next application is displacement. Displacement is net change is integration displacement rate of change for displacement from t1 to t2. The electric energy is integration energy prime dt and t1 and t2. What is the physical meaning of E prime is dE over dt. We define this physical value is power. So this is T1 over T2 and power dt. This is the net change of electric energy from T1 to T2. So we take an example. The particle moves along a line, the one-dimensional movement, and velocity is t squared minus t minus 6. Find the displacement of the particle. It means if we let displacement is s, we want to know the net change for displacement from t equal 1 to t equal 4. Its net change is integration rate of change of displacement from 1 to 4 dt. So what is physical meaning of derivative of displacement is velocity. This is vt dt. So integration from 1 to 4 t squared minus t minus 6 dt. So it can be 1 over 3 t cubic minus 1 over 2 t squared minus 6t from t equal 1 to t equal 4. We can calculate this. This 1 over 3 multiplied 4 cubic minus 1 over 2 multiplied 4 square minus 6 multiplied 4 minus, we input t equal 1 into this formula, 1 over 3 minus 1 over 2 minus 6. So the answer is minus 4.5. 4.5, and this is net change of the displacement. This is the unit is meter. So find the travel distance on t equal 1 from t equal 1 to t equal 4. The travel distance is absolute value of displacement. This is we can find displacement is integration rate of change from x t equal 1 to t equal 4, and travel distance is absolute value of rate of change. So it means it's integration 1 from t equal 1 to t equal 4. The absolute value t squared minus t minus 6 dt. So we can draw the graph. We can now graph the t squared minus t minus 6. We let ft is t squared minus t minus 6 is this is t minus 3 t plus 2. So we can draw this curve. This curve is minus 2 3. Range is 1 equal 4. So when from t equal 1 to t equals 3, this value is negative. So minus t equal 1 to t equals 3, t squared minus t plus 6 minus 6 dt. Minus 6 dt. And from t equals 3 to t equals 4, this curve is the value of this curve is positive. So t squared minus t minus 6 dt. So we can find this minus 1 over 3 t cubic minus 1 over 2 t squared minus 6t from t equal 1 to t equals 3 plus 1 over 3 t cubic minus 1 over 2 t squared minus 6t from t equals 3 to t equals 4. We can calculate this integration, and this is 61 over 6. This is the answer. And this is the answer. And this is done. So today, we discuss about the net change of some variable. The net change of some variable is integration from starting point to end point, the rate of change of that value. Thanks for listening to this video, and see you next time. Bye-bye.